Welcome, everybody, to our second in a series of webinars by the Vera Rubin folks. I am not going to spend a lot of time talking to you. I am going to turn the program over to them because they have so many good things for us this evening. Thanks for spending part of your evening with us.
Hi everyone, I'm Dan Peluso. I'll be joining Colleen on talking about some of the modeling stuff. I'm also going to let the Vera Rubin folks here, Artist and Justine, kind of take us in the lead. I have some very exciting things to show you about a really awesome project and great education activities that you can use. So thanks for coming. We look forward to having this workshop with you today.
I'm Artis, and I work at Rubin Observatory in Tucson, Arizona, formerly a high school science teacher. And we've been working together now for about 7 or 8 years, developing these activities. And Justine Shane, I will, my trusted compadre in all of this. So I'll turn it over to her.
Thanks, Artis. Welcome, everyone. I am Justine Shane. I work for NSF Noir Lab as an education specialist. And a lot of my time is spent working with Vera Rubin Observatory and Artis on these investigations. And so I'm really excited to take a deeper dive today into surveying the solar system investigation from a modeling perspective. So this should be a lot of fun. In our previous slide, when you were all joining, if you were early, let me go back to that. I was hoping that everyone could tell us about themselves in chat if you haven't done so already. Where are you located? Someone here is from Scottsdale, so it's nice to have Arizona represented. So I'm in Arizona right now, same with Artis. So welcome, Scottsdale. And so tell us, where are you located? What's your current role and what grade levels do you work with? So everyone is welcome here, whether you are an informal educator or classroom educator, whether you teach at the middle school level or college level, you are all welcome. And we hope that you take away something that you can use back in your classroom or your practice by the time the webinar ends today. And so with that, I'm going to turn it over to Artis.
Okay, thanks, Justine. We just have our code of conduct up here that we always like to display at the beginning of the meeting, realizing that we all come from different perspectives, we have different backgrounds, and just ask that we treat each other with kindness and respect and be present for what we do today. We realize this is really valuable time for you, especially in this month when a lot of crunch things happen. So we're really excited that you're with us today, and we appreciate your presence. I'd like to talk just a little bit about this workshop. We did a workshop previously in October. Some of you were there. Some of you may not have been there, and you're joining for part 2 of this workshop. So in our previous solar system workshop, what we did is we talked more about the design of our investigations, the different investigations we have available, and a lot of the more background material in terms of how the investigations work, etc. Today, we're going to focus in on really doing a deep dive into the solar system investigation, which we just briefly looked at in the last workshop. In the last workshop, most of the time we spent on the solar system was in working through the phenomenon and talking about ways that that could be implemented in your learning context. And so today what we're going to do is really give you more time to work interactively with the investigation and with each other. The solar system investigation is working right now based on proxy data because some of you know, or maybe all of you know, that Rubin Observatory is not yet online and producing its own data right now, but it will be by the end of this year, in a year from now. So one of the really exciting things about Rubin Observatory is because of the unique design of the telescope and the survey, we are predicting to really amass a huge number of solar system discoveries. And so you can see in this chart how many objects are currently known. For instance, near Earth objects around 20,000. We expect to increase that number to 200,000. So if you look at these numbers, they are very, very significant. And the reason this is important is it helps us build a more complete model of the solar system by adding in all of these small bodies. It also helps us understand better the formation and evolution of our solar system. And so this is an investigation right now where you're using proxy data, but in a year from now, hopefully you'll have real data from Rubin to work with. Okay. Our investigations are designed as drop-in lessons. It's not intended that we present an entire curriculum in an investigation. They're designed to take about 2 hours in the classroom. You can expand that and go deeper and spend multiple days if you'd like to, but 2 hours is really kind of a sweet spot for most of our investigations if you work through the online component like we'll work on today. And because these are drop-in lessons and they might be used in different places depending on what you're teaching, we always include prerequisites that are part of our teacher guide. And so the teacher guide will list not only the learning objectives and the prerequisites, but it'll give you a lot of really great background information that'll be helpful in going through this investigation. And so we wanted to frame what we're going to do today in terms of you thinking about, imagine that you have already introduced these concepts. And this is going to be a kind of a follow-up and an implementation and a going deeper activity into these ideas. All of our investigations are designed to support the next generation science standards. You can see we have a tricolor statement there that keys in to what science and engineering practices, disciplinary core ideas, and big ideas, cross-cutting concepts that we attempt to integrate into this three-dimensional learning into this lesson. We also recognize that a lot of you might be physics teachers who are teaching high school physics, but are required to also teach Earth space objectives or in your physics classroom. And because of that, what we have for each investigation is an alignment chart showing that when you are teaching about gravity, for instance, this is a great place to bring up the Earth space objective about the motion of objects in the solar system, and so on. So just wanted to make you aware that in the teacher guide of each investigation, we have these Earth space physics alignment charts that hopefully will be helpful to some of you. And for each investigation, in addition to the online component where we're going to spend most of our time today, we have a variety of different assessments, a pre-test, post-test, formative assessments, some other assessments we'll talk to you about later that are more like a summative assessment. And if you'd like to look at any of those assessments, you'll notice they're in teal on this slide. That means you need to create a free account. And the reason you need to do that is we want to keep students out of the assessments because some of them have answer keys. Now, some of you I know already have created accounts, but if you'd like to use any of the assessments, which by the way are downloadable and modifiable, just create this account. It doesn't have to be tonight because we'll give you a quick link to view them. But when you do, be aware that there's going to be a little delay because we actually vet everybody who applies for an account and we check to see if they're really a teacher of some sort before we give them access. Now, this is a money document that we would like you all to get to right now if you can. Notice the link on the side where it says ls.st/links. And Justine just pasted it also in chat. This is a one-stop place you can go to tonight to click on any of the resources we have available for this investigation. And you'll notice they're organized by different areas. At the very top, where it says Surveying the Solar System Investigation in white letters, if you click that on your links document, it will take you immediately to the start page of the investigation. And so please keep this open as a window as you go through our investigation today, because you may want to go back. And the only thing this does for you is it allows you to quickly access all of the materials instead of having to go to the website and click through a few links to get there. Okay, I think Justine, you're on next.
Thanks, Artis. Okay, so in our last webinar, we introduced the phenomenon activity for surveying the solar system. And I recognize that there may be some new people here. So I just wanted to do a quick recap of what we talked about in our last webinar, just to catch everyone up to speed and to jog everyone's memory. So for all of our investigations, we provide an investigative phenomenon. It is optional to do it, but why I really like the Surveying the Solar System one is because it's a great modeling opportunity. So the point of the phenomenon is to have students start to make sense of the natural world, and they're starting to make sense here of asteroids and and these small bodies in our solar system. We provide you as an educator with a driving question, like a big question to help, target student questions as they're watching the video. The driving question is that Rubin Observatory is going to discover thousands of solar system objects. Okay, and we want to know, does one of these objects belong to a group that already exists? Or is it a brand new type of object? Doesn't even come from our solar system. Is it coming from outside of our solar system? So there's so many different possibilities here for what Rubin is going to discover. And so that's a really big question. So we want to help students start to make sense of this. So there's this great video. I'm not going to play it, but it's like a time lapse of asteroid discoveries from 1974, or it's from 1970 to 2015. And I just took snapshots of 6 different points in this video. And so what students are going to see, they're going to start to observe, okay, in 1974, there's not a lot of asteroids being discovered. That doesn't mean that they don't exist yet. That might be like the first misconception you have to address with your students. But they might start to notice, because everything's in motion, that you have the sun and you have some planets going around the sun. And then as they continue to watch the video, they're going to see, oh, there's these little objects that are starting to be discovered, and they're color-coded. And so all we want students to do while they're watching the video is just observe. What do you notice? Okay, and then they can work in groups to share what they're observing. We created in our last webinar a driving question board, and we started to write down things that we started to observe as learners. So some of those things are, the sun, the planets, there were flashes of lights happening, and there's different colors. Okay, and then after we say what we're noticing, we start to ask what we're wondering. What questions do we have based upon this video? And it can be any questions. We would encourage students to write some scientific questions and questions that we can investigate, but we can weed through those later. But all questions are welcome. And we posted these on our driving question board. And this is going to help students have ownership of their learning leading into the investigation. So as an educator, in your back pocket, you have this investigation that you're going to give them so that they can work with real data to start to make sense of this. But we're going to use their questions, and most likely students will ask, oh, what are these different colors? So there's this green group of objects, there's this like yellow group of objects, and there's a red group of objects. And they'll probably have many other great questions, but this is a starting point that we can use to lead into the investigation. So the first question that we might start to answer is, well, what are the different groups of objects in our solar system? Besides the planets and our star, what other groups exist? And then that leads us to our investigation. Now, I want to point out the modeling opportunities that we have here. So we have this modeling cycle from AMTA where students develop a model to make sense of a concept, right? And there's many different steps to this. It's a cycle. It's an ongoing cycle. There's no direct place where you need to start, but we have provided them with a phenomenon. And they have asked questions already. And then what we're going to do is we're going to give them the data to work with. And that's going to lead into some model development and the opportunity to refine our models. But it's also a great place to make predictions. At the very beginning, before we give them the data, let's just make predictions. So One thing I wanted to point out in this video is that we have our planets, it just goes up to Jupiter. We're only seeing asteroid discoveries to Jupiter. So what lies beyond that? And this is something that we can ask students to model on their whiteboard. So model what you see here in the video for our groups of solar system objects, and then make predictions for what you think lies beyond Jupiter. And then they can always refine their models. Let them know that they can always change it. What they write down is not necessarily the right answer. We're going to get more information just as astronomers do. Dan, did you want to add anything to this slide?
Yeah, I do actually, very briefly. Thanks, Justine. So one thing you'll notice in that graphic is a whiteboard. So if you're kind of not familiar with modeling instruction and with the American Modeling Teachers Association, one of the simplest and very effective tools for student engagement and creating these models is an old-fashioned whiteboard. So we get a whiteboard that is big enough for a group of 3 to 4 students to huddle around, with each of them having a marker. And a great way to engage them is to actually have them ask these questions, to write down what they observe from the phenomenon, as Justine said, and then have each group stand up with the whiteboard, and you have what we call a board meeting. And in each student group will talk about like what did they observe in the video, and what questions they have. And this is a great way to have discourse with your students, to have them engaged. Okay, the teacher becomes the guide on the side. The students are leading the learning, and they're starting that engagement right off the bat. And then they go into the next part, and we continue back to the drawing board over and over again through this cycle that Justine very greatly pointed out to us.
Thanks, Dan.
Mm-hmm.
All right, so now is our time that we're going to start to get into the investigation. So there are different concepts that are introduced in the investigation. I want to point out that at the beginning, there's a lot of vocabulary that's introduced to students, and this is a trend in all of our investigations. We just want to make sure that students, we're not sure where every student is coming from, what their background is, what type of vocabulary they've been introduced to. So we do provide some tools that they need at the beginning to help them make sense of data. So at the introduction, they're going to have some background information about the solar system and starting to understand our solar system and the shoulders of giants that we've relied on to help make sense of our solar system. And then they will be given data, and they're going to start to characterize small objects in the solar system and get familiar with the different groups. Eventually, they're going to take that learning and apply it to trying to understand the formation of the solar system and orbital interactions. And then by the end of the investigation, they're going to be given a brand new scenario, brand new group of objects that they need to try to categorize. And finally, all of our investigations end with a reflect and discuss section where they get to summarize all of their learning and just really show what they have understood in the investigation. So with that, I would like you all to go to the links document, and I will just do it with you so we can make sure that we are all at the right place. So on the links document, you have this top link for surveying the solar system. So click on that and your screen should look like mine. And I will also put the direct link in chat. And then don't start it yet. I'm going to give you all a passphrase. And this passphrase, I'm just going to put it up on the screen here, is educator mode, and the E's are replaced with 3s and the M is capitalized. And all this does, this is just for educators, it's not for your students. All it does is it helps you go from page to page of the investigation without having to type in answers. Your students need to type in answers before they can look at the next page of the investigation. They can always go back and change their answers. They just cannot move forward. So again, that passphrase is educator mode, and then the E's are replaced with 3s. And we also wrote that on your links document in case you forget in the future. You can always go back to links document and check that out. But you don't need it. You don't need it. So if you're doing this with your classroom and you happen to forget it, you don't need it. It just it's not that great because then you can't help a student that's necessarily on like page 20, let's say, and you're still stuck on page 1. But there's workarounds to that. Okay, so you should have all put in the passphrase. And I will do that too. You press this toggle button. If anyone's having issues, please let us know. Then you can press start. All right, you can see here that we have our introduction page, the background page. And what we're going to do now is we're going to go into breakout rooms, and I'm going to have you stop at the end of page 12. When you get to the end of page 12 with your breakout room, you can feel free to continue to have a small discussion if you want. You can talk about modeling techniques, or you can come back to the main room here, and I'm going to have a reflection question posted for you. So you're going to work until you get to the end of page 12 with your groups. It's best if one person in each breakout room is sharing their screen. That just keeps everyone together. That person is not in charge of the answers necessarily, but it keeps everyone together. You don't have to read the entire narratives aloud. You can kind of scan through them. But yeah, am I missing anything, artists? Okay.
Did you want to point out like table of contents and
Oh, sure.
the little thing on the top and
Yeah, so you know that you're going to get to page 12 when you get to this first pin here. And it's also, you'll see like a checkpoint button on page 12 right here. This is where we have some formative assessment opportunities, and we're going to share one with you today. You don't have to stop in your classroom, but this is a great place that we recommend you do stop because new concepts are going to be introduced. And if you don't have the concepts down in part 1, you will struggle with part 2 and 3. So we have our table of contents on the left. You can review your answers with this star here. This is a great way if you want to like print out student responses. You can do that on the review your answers page. We also have acknowledgements on that page too. So you can see where we get data from and who has contributed to vetting this investigation. And then you can also toggle between languages at the top as well. So English and Spanish are what we have them available in. And then if you happen to speak another language and you're working in Google Chrome and you would prefer it to be translated to your language, you just have to right click and then select translate to, and then you get to pick what language you want to translate it to. And it works pretty well. Okay, great. All right, so do we have breakout rooms ready?
We do have breakout rooms ready, 3 breakout rooms. So, ready to go? How many minutes do they have?
We have about, let's say 25 minutes. Artists and I are gonna, and Dan, we're gonna pop into the breakout rooms. And if we think you need more time to get to page 12, you can certainly have it. But what we're thinking it's gonna be about 25 minutes to get through that.
All right. Ready, set, go. Your rooms are open.
Welcome back. Do not worry if you did not finish part 1. Some groups finished, some did not have enough time to finish. When you go back into the breakout rooms, you can just pick up right where you left off. But we wanted to bring everyone together as we're approaching the end of section 1 before we go into section 2. And we first want to start off with some individual reflection time about modeling. So what you've seen so far in section 1, have you seen any modeling opportunities that could support student understanding? So I'm going to give you some time to think about this. So we have a question. What do we mean? We're talking about modeling to support student understanding. So like maybe some whiteboarding opportunities that you'd want to do with your students in section 1 to try to help them understand, for example, some concepts that were introduced. So I just kind of tried to leave that question very broad, depending upon what your background is and what you teach. So for example, if I were to teach at the high school level and I hadn't taught eccentricities yet, I'd maybe want to ask my students to model for me an orbit that has high eccentricity or an orbit that has low eccentricity, and then see if they really understood what that term means. So that's just one example that you could do, but I feel like there are others depending upon your background and your and what you teach with your students.
Yeah, and I could add too that, if you don't have experience doing modeling instruction, if you're not a modeler, you do this concept of modeling, you could just think about in science, we create models, right? A model is, something that represents a real thing in nature. And how would you maybe talk about, how you're creating a model of a solar system and, what kind of modeling questions or activities might you do based off of this activity that you spend some time with?
Yeah, and I'm just going to chime in for a second and say that a model is a representation of structure. So there are different kinds of ways that you represent structure. Maybe it's a diagram, maybe it's a graph. In physics, maybe it's a set of equations. But what we are talking about is how might you ask your students to represent the structure of the thing under investigation. And multiple representations that represent the same thing in different ways are really powerful learning tools.
Great, thank you. So I'm going to give you, oh, go ahead.
Sorry, I was just going to say, because one of the things I was thinking about is if I had my students, because we're starting with the near Earth orbit, so maybe having them draw a diagram of what they think that looks like, and then maybe in a different color adding the next layer, and then in a different color, adding the transient Neptunian objects. So as they're actually working through this piece, have that diagram and add to it as they're going.
Tracy, that's such a fabulous idea. I love it. And you want to know what? So when you go into the next section, that's when they're going to start to visualize each of the orbits. So having them do their own whiteboarding first and drawing the orbits of these objects before they even see it, that's just brilliant. I love it. Thank you for sharing. And Trina sharing an activity with ellipses. Thank you. Okay, and I'm going to provide a couple examples of some resources that we share with you as well. So at the end of page 12, there is this checkpoint section. So this is a great place for you to tell students, okay, stop when you see this checkpoint at page 12. And if they're working in groups, you can come and walk up to this group. You can ask them some quick formative assessment question just to check, make sure that everyone's on the same page before they move on, or you can do a whole class question. So for example, I have this question up here and we'll answer it in waterfall style. So what I mean by that is you're going to put either A, B, C, or D as your answer in chat, and don't press enter until I say so. Okay, I'm going to give you about 15 seconds to read the question. Think about the best answer, A, B, C, or D, and then put that in chat and get ready. Don't press enter until I say so. Okay, and we're going to waterfall in 3 seconds. 3, 2, 1, waterfall. So that's when you press enter. Okay, awesome. Thank you. We have some great options here. We have some of us think C, some of us think D. So it looks like we have all eliminated as a group A and B. So we all agree A and B are not the answer. So the question was, which of these inclinations indicate that an object is orbiting opposite to the direction of the planets? So this is where if your students are not sure of what the correct answer is, you have a divided group, have them go back into the investigation, have them provide evidence for why they think the answer is C or why they think the answer is D. And they can do this with a partner as well. So they can turn to their neighbor and say, I think the answer is C because, and they can go back into the investigation. That's okay. Support why they think it's that. So I'm going to go to the next page. Here, the answer is D, 120. And there's a great little movie that we have or clip that introduces inclination. And it shows the planet going on its orbital plane. And you can watch the angle change. And you see it turns to orbit opposite the direction when it gets to an inclination of greater than 90 degrees. So you can bring this back to your students who may be struggling with inclination. So out of those options, A, B, C, and D, the best answer was D, 120, because it was greater than 90. So how could we turn this question, though? Maybe you're not a multiple choice sort of person, or you want to do modeling with your students. How can we turn this into a modeling question? So as a quick formative assessment check, you could have students draw in their notebooks, draw on a whiteboard, a model of an object orbiting opposite the direction of the planets, and label your model with one possible angle of inclination for that object. So we provided the multiple choice question, but you can take any of our formative assessment questions and turn them into questions that fit your teaching style. And this is one that just fit really well to turn into a modeling activity.
Justine.
Yes.
Yeah, I have a photo of students actually using a modeling whiteboard doing inclination I could show at some point too. As an example, I was able to find one while we were going through some of this.
Oh, that'd be amazing. Do you want to share? Are you going to share your screen? Or
Yeah, is that okay to share real quick?
of course, let me stop mine.
Yeah, and this will also just show an example of what it looks like when students have that board meeting that I mentioned earlier in a modeling classroom. So these are some of my students from last year, and they are modeling the inclination. So what we did is we had them use flashlights actually and hold the flashlight at different angles, and they used some tools in order to figure out the angle that they're holding the flashlight to help them understand inclination angles. And then this led very well to thinking about things like eccentricity. There is just another example of students having a board meeting here. This is a different type of board meeting on something maybe some of you are interested in, or some of you might know of. Person by the name of Eratosthenes did some sort of loud experiments several thousand years ago, and we have a modeling activity in our modeling workshop where students do that.
Yeah, he and I were in school together. Eratosthenes and I.
Nice. And then I had one more to show. I just have to switch screens real quick, and then I'll let you get back to your slides. Trina mentioned a modeling activity using, I think like what, push pins or something maybe. We can also do this on a whiteboard with suction cups. So we can get suction cups and then string, and then we can make, different, shapes of different eccentricities and teach students how to measure the C and A. These are basically the distances and within an ellipse that gives you the eccentricity, and they're able to divide those to figure out how eccentric an orbit is. So this is a fun little modeling activity for them to really help them understand modeling by actually creating the orbits and drawing them and doing some basic math. So we'd probably, through the course of using this Rubin activity, do some of these activities in tangent with actually going through the online module as well, I think. And it really does help students, I think, to understand the the process of how eccentric orbits work by actually drawing them out and measuring things and actually doing the math. And then when they can see the visual, then they, oh, we actually drew that. We did the math. We know what you're talking about now because we made it. And that's really helpful for them.
Awesome. Thanks for sharing that, Dan.
Yeah, this is an even better picture you
Yeah.
have on here. Sorry.
Yeah, this is one from your modeling as well. Just an example. So also at this checkpoint, you can have students go back and refine their model. We had them make predictions about what lies beyond Jupiter. But here now they can draw the whole solar system from what they've learned. They can use their table if they need to. And we're asking them to draw a top and a side view models just so we can see inclination as well. So draw the entire solar system to now include TNOs and comets. Maybe they can start to identify some of the groups that were in that phenomenon video as well of the asteroid discovery. Maybe they can now identify what the green objects are and the red objects as well. So this is a chance for them to go back and refine their models. And then Dan, did you want to talk a little bit more about this whiteboard here?
Yeah, so this is very similar to the one that I showed just a moment ago. So after they learned about eccentricity, we also taught them about perihelion and aphelion, about these closest to the star in its orbit and farthest from its star in its orbit. And we started introducing these idea of like forces. So why might there be these weird orbits that we have? And just asking that question, and then without even talking about gravity yet. So we didn't even say what gravity is. We didn't define it. We didn't show a definition. We just said, well, why do you think this is happening? And then some groups had no idea what, they were like, I don't know what's going on, right? But some groups would be like, have you heard of gravity? I think it's because of gravity. And even if some groups didn't, in a modeling classroom, you might go to a group and be like, what happens if I drop this pencil? And they'd be like, it falls. Why? Because of gravity. Oh, that's something to think about. And then you leave the table, right? And then you plant the seed at that table. And then hopefully at that point, maybe they come up with something on the board. And maybe you don't tell any of the other groups that. And then you have your board meeting. And then no one else figured it out. And then that group did. And you're like, oh, they have an interesting thing they're talking about, right? And then that group is like, yeah, we got it. We're smarter than you. And they'll make fun of all the other groups for not coming up with it, even though you might have planted that seed, or maybe you didn't. But the point is you're letting the students kind of figure out. And sometimes the class teaches itself when you get really good at this modeling stuff. And you come up with cool boards like this.
Awesome. I do see a great question in chat. Since we're at the checkpoints, this is a great time to just remind you where you can access these all these questions that we have. So on the links document, if you see assessments and if you click on formative assessment, that's where you're going to have access to a document right away with some quick checkpoint questions here. And it's divided into each section. So we just did section 1, which ends at page 12. So we have questions that help show students' understanding of concepts introduced in that first section. You can only access these assessments since you're on this webinar, you can access them right away. But to get the other assessments from our other investigations, you do need to create an educator account, which Artis will talk a little bit more towards the end of the webinar today on how to create an educator account. And she just mentioned it takes a little bit of time for us to make sure that you are a teacher. We don't want students to have access to these questions. They're for you to use to make sure that students are ready to move on to the next section. So we have our assessments on this links document here if you want to take a peek at them now. And then when you access them online, you get the doc as well. So you can edit them, turn them into your own questions, put in your own answers. So if there's, some wording that is not typically what you use in your classroom when you teach, or if it's multiple choice and you don't like multiple choice questions, you can change it to be whatever you want. What's nice is you can copy and paste them as well. So say that you use like Kahoot or some other some other polling website to gauge student understanding, you can just copy and paste them right into that platform. Okay, I think we're ready to get back into the investigation. In this next section, students are going to start to visualize the orbits of these small bodies. And they're also going to think about how the orbital properties support the solar nebula theory, and some orbital interactions as well. So I think we're going to give about 15 minutes for this next section to be in breakout rooms. And if you did not finish section 1, you can just go back. We really want you to go back and finish section 1. There is a nice table that you're filling out as you're looking at TNOs, MBAs, comets, and we want that table to travel with you through the investigation.
Opening the rooms. See you in 15. Very cool.
Okay, well, welcome back again. We just kind of skipped coming back and then putting you back in breakout rooms just for sake of time. So you all went into section 3, the final section. I don't believe either group had time to quite wrap things up and finish the answers, but hopefully you have a good taste for what's to come. Also, due to time, I'm just going to kind of go really quickly through this individual reflection question. What are some modeling opportunities now? You just saw at least one new section that could support student understanding of section 2 and 3 if you made it well into 3. So if you have any great ideas, please feel free to just type those in chat. And I'm going to move forward and share a modeling suggestion for connecting back to the phenomenon. So when students finish or get to the second checkpoint at the end of page 20, they've talked a little bit about the solar nebula theory, and they can go back to their models and now construct an explanation. So this is part of the modeling. Now use your model to come up with an explanation, use reasoning as well. So how does our model of objects in the solar system, or by using the video, support the solar nebula theory? And I was hearing some great discussion in the breakout rooms of what to expect possibly in these student responses, such as them talking about how well most of the objects are orbiting in the same direction to the planets. They have similar inclinations. So it suggests that the objects formed the rotating disk that surrounded the young sun. So they all formed around that same time in that rotating disk. In section 3, you may or may not have gotten to this yet, but I just wanted to highlight that in this section, students start to evaluate other models. So they look at student team A, student team B, and student team C, their models of a new set of solar system objects. So this is a new set of objects. It's real data. It's a real set of objects. And what they have to do is try to figure out which models, A, B, or C, best represent the new set of data. So they use a little bit of evaluating, a little bit of argumenting from evidence as well to help evaluate which one is the best. Also in section 3 on page 30, there's a set of questions where we want students to bring in their own experiences, no matter their understanding of science or background in science. So we have these questions where everyone can hopefully come from the same level and answer these questions. So we bring to them a new scenario where they have to propose a name for a new set of objects and design a media strategy to announce their discovery of objects. So this is one that they could work on with groups. Maybe they present this to the whole class as well. But all of our investigations have these questions where it doesn't matter what their background is, and they could bring their own experiences to try to answer this. We've had some teachers share like, oh my goodness, my students would love to make like a TikTok video to answer this question, to try to spread awareness to the whole world that a new set of objects were discovered. Okay, let's get to some assessments. So these are some resources for you to help you in grading and providing feedback to students. As you've noticed, there are a lot of questions on these investigations. I believe this one has like over 50 questions, and what teacher has the time to grade 50 questions for a whole class? So we have identified like the money questions, the questions that summarize students' understanding of a particular concept. and we've broken them down by row. So for example, on the key assessment questions document, which you can access right now in the links document that we shared at the beginning of the webinar, this first set of questions are showing students' understanding of orbital properties. And then we also highlight for the high school teachers, maybe your state has adopted some form of the next generation science standards. We've broken it down by science and engineering practice and cross-cutting concept as well. So you can see how they're using each of the dimensions to answer those questions. Okay, and then finally, I want to take some time to review the summative assessment. So the point of the summative assessment is that we highly encourage students to be working in groups when they're doing the investigation. And then you provide feedback to them with how they did on the investigation. You hopefully cover any misconceptions that they still have. And then you can give them a summative assessment. And this is something that you can just print out and hand to your students. And this summative assessment, it asks them to do some modeling. So we present them with a scenario, a new phenomenon that there's new solar system objects, A, B, and C, that have been discovered by Rubin Observatory. And what we want them to do is classify these objects. But before they can get straight to the classification, they need to do some modeling. So we have them show us the orbits of A, B, and C with a top view model and a side view model. And hopefully the investigation has prepared them to do the summative assessment. And then the last part, they have to then classify each of the objects as an NEO, MBA, or TNO, or comet, and explain how they know. So we also provide a scoring guide. We recommend giving the scoring guide to the students up front so they know exactly how they will be assessed. And then as an educator, we provide an answer key for you for the summative to hopefully help you with the grading process. We provide some possible student responses and how we would suggest grading it based upon a standards-based grading approach, where 3 would be meeting our expectations. That's what we want them to get, a 3. But there are opportunities for them to show understanding beyond a 3, exceeding our expectations. So we tell you what some examples are of that and where you might see that in the summative assessment. And I believe I'm turning it over to Artis.
Kathy has a question about where do we find the answer key for the questions within all of the pages? And Kathy, are you talking about the assessment, the investigation itself, like numbers 1, 2, 3, 4, etc.? Okay, we don't have an answer key for that. And there's a few reasons why. One is that some questions are open-ended and they don't have a specific answer. And as I mentioned to our group, when we get to page 22, for instance, even though the students don't know this, the data are randomized. So not everybody has the same asteroids to look at. And so there isn't like one correct answer that's always going to be true for, let's say, page 22. Oh, now, you are not the first person who have brought this up. And we have started working on partial investigation answer keys. Right now, we have only one done. It's for expanding universe. Solar system will be the third one we do, but it's probably going to be a little while yet, maybe a month or two before we can get those out. And if you are in our communication lines, our community of practice, we will announce that and you'll know as soon as we have it online. How do you know if students are getting the right idea? So you're saying that maybe you're not sure of the answers either because this is new. Okay, great. Well, one thing I would suggest that would be helpful is take a while to read through our teacher guide. I think, Justine, do we have a slide there that talks about the components, or have we already done that? Oh, okay, yeah, that's great. So on the links document we gave you, there's a link that you can click on the teacher guide. And especially for people new to teaching these areas, there are 3 sections we really recommend you take a look at. One is the background, because that gives you a lot of information about how we built the investigation, what all these things mean, et cetera. The second one are teacher notes. And again, this is more technical things that might be, you have a question about what's the difference between the Kuiper belt and the Oort cloud or something like that. And then the third part, which is really, really good, I think, is common student questions and ideas. We will tell you what your students are likely to ask you and how you could answer them. We will also tell you what your students will struggle with or get confused about and how you might help them bridge that understanding. And so those 3 sections in particular, I'd recommend to look at the teacher guide. And then in the teacher guide, sometimes we have links to other resources too, if you need more information. I'll also mention that all of our investigations are linked with the OpenStax free online textbook for astronomy. And
That's great.
so we will link like specific sections of the astronomy OpenStax textbook and say, hey, if you need more information about this, look at this section. And then you can get a lot more detail of things. Okay, thank you about the teacher guide font. So the slide that Justine has up here, everything in teal on this slide, we have a teacher guide, video, speaker slides for each investigation out of our 7 investigations that you can use. In addition, we have some general resources on our website. The program guide talks a little bit more about the design of our investigations. And the professional development page, I have a slide on, so we'll get to that. Is that the next slide, Justine, perhaps? Yes. So we have a page on our website for professional development resources. One of the things we have there are recordings of all of our webinars where we unpack these different investigations. So you can go back and listen to the recording of any webinar you might like. We also have a community of practice that we'll invite you to join. And we are willing to, if you have a department or a school or a district that wants to get more training on all of our investigations or a specific one, we're happy to do that for free for you online. So just let us know. And in addition to that, I will tell you that Justine and I are actual human beings that provide real near-time support for you. So if you write to us and say, I've got a problem, we're going to get on it as soon as humanly possible and get back to you. So our web pages are not static resources. They're backed with real live humans. And we have both been teachers for decades. We understand what it's like to be in the classroom, and we want to support you in any way possible. Okay, moving on. If you're interested in joining our community of practice, we have 2 different kinds. One is a social media Facebook group. You can just search for Rubin Observatory Educators and join it. Remember to answer the membership questions and agree to the rules. If you do not like to do social media and you would like to have a discussion group with other people using these investigations, we have an email discussion list. We're going to ask you in a minute to fill out a workshop evaluation. Just check the box if you'd like to be added to that, and we will do that. All right. And finally, we don't have a lot of time left. I appreciate your patience, but we would like to ask that you fill out 2 surveys, and we also are happy to stay here and have some discussion with you if you have more questions. So the first one is the AMTA webinar survey, which is pretty quick. I think Colleen says 4 or 5 questions.
Yeah, it's really short.
Our
And-
investigation looks a little longer, but it's mostly just clicking on things. So
Yeah.
if you could do that, that would help us out as well.
Also, I'm putting in the chat a link to for anyone who wants a certificate of attendance for this webinar. So if you need a certificate because you're, gonna record professional development hours, this is the survey you fill out.
And we would at this time open it up to anyone who has questions or comments. as you're filling out your surveys or
I got
thinking
the
about next.
AMTA survey.
Yeah,
Sorry.
I reposted it. I realized that I sent it just to you.
I also just want to add to artists mentioning, like it's us behind the scenes. So if you do get stuck on some questions and you're not too confident if you know the right answer, you can also email us. I just responded to a question last week that someone was stuck. I think it was actually on this investigation surveying the solar system, and I helped to give them some direction on some answers. So even though the answer key isn't ready yet, you can always ask us, even if it's not for expanding universe. You can ask us about any investigation and be like, what is going on in section 1? Can you help me? So we are able to do that as well.
And I know somebody asked, and I apologize, I don't remember who, wanted to know how to set up an account to view assessments. And so I'd like to leave this. Oh, okay. I was going to say I'd like to leave that link up there, but maybe we have both of the evaluations in chat now, right?
Yes.
Yeah.
So everybody can access them. So I can share my screen and show you how to get there.
Yeah, and a good idea too before you leave the webinar to save the chat too, because you always have those links and you can look back at some of the things that were said.
Yeah.
Also, this webinar will be posted on the AMTA. The video of this webinar will be posted on the AMTA website.
Awesome. Thanks, Colleen.
Okay, so this is the main site for Rubin Observatory. And if you're on the main site for the observatory, you will either see a menu bar across the top, or depending on the real estate on your screen, it might be on the side. If you go to the education pages, go to educators. And there are some different resources here, but the one that's important for you right now is the one that says learn more about our investigations. So when you click here, instead of being taken to an investigation, what? Hold on a second.
Websites love to do that when you're presenting.
Yeah, right. Okay. So instead of being taken to an investigation, it goes to our landing page, which is a page that goes through. Now I don't know what it's doing. Okay, there we go. So let's say we did surveying the solar system today. So we're going to click here. And what it will take you to is a suggested sequence of how to unpack the investigation. So the first thing we suggest is read the teacher guide. That will answer a lot of your questions. Then this will take you directly to the investigation, or click that big button up here. But notice that number 3 says examine the assessments. So if you click there, everything here is accessible to anyone, teachers or students alike. But the assessments are not accessible to students. So at this point, it will say log in or sign up. So to sign up, you can either sign up using your Google account or with email. And again, just remember there will be a little bit of a delay. If you sign up for these assessments tonight, we'll get you up and running tomorrow. But if you choose to do it Saturday night, we might not see your message until Monday morning. So, but just remember there's a little bit of a delay, so we vet the people who are there to make sure students are not getting onto the site. And if you're an informal educator, like we've got people like, Kathy that does Girl Scouts and stuff. We know who you are if you've been on one of our workshops. So don't worry about getting in, because we'll know who you are. But occasionally we get homeschool teachers or something like that, and we send an email to them and say, hey, we can't verify that you're a teacher. Can you help us out? And then they'll send information back. Okay, that's all I have to show you, unless people have other questions.